Hi everyone, in this lecture we are going to talk about broadcasting. One of the most powerful features that NumPy offers is broadcasting. Broadcasting is what allows NumPy to work with arrays of mismatched shapes. In order to understand what broadcasting really means and to see the rules that it follows, we need to first talk about the definition of the broadcasting. And the definition is on the screen. You can pause the video and just read it and digest all the aspects of the definition. The definition that you see on the screen here is a little bit too long, but it's pretty clear that broadcasting refers to how NumPy treats arrays with different shapes when you perform operations on them. Now, you may not have realized it, but we have already used broadcasting in the NumPy operations so far. What we have seen so far are broadcasting scalars. You can always broadcast scalars to work with NumPy arrays. Broadcasting is best understood visually, so let's see what it means to broadcast broadcast scalars to work with arrays. Let's consider a very simple array here. An array which contains 6 elements, which are all ones, and you want to multiply this array with a scalar with the value 10. Now, this is an operation that we have already performed. Some sort of this operation we have already performed when we were talking about NumPy. We saw that every element of the array will be multiplied by the scalar, and this is what is broadcasting. Now, what exactly happens here is that the scalar 10 is replicated to match the shape of the array, to match the 6 elements that are present in this array. Once the scalar has been replicated so that the dimensions match the original array, we can now perform element-wise multiplication to get the result, which is an array of 10s. 6 elements all equal to 10. NumPy has broadcast the smaller array, which in this case is the scalar, to match the dimensions of the larger array to perform this arithmetic operation. All right, and here is the result. Now, broadcasting works with multi-dimensional arrays and scalars as well. Here we have a 3 by 6 array represented by a variable ARR and a scalar 10. This multiplication operation will first replicate the scalar s along the columns and then the rows so that the array shapes match. An element-wise multiplication can be performed. And finally, the result is going to be displayed below. The result is displayed below. So the scalar 10, it has been stretched to contain all of the data that we've had, to match the shape of the scalar with the shape of the array so we can get the result. Now that we have understood broadcasting, specifically when we use arrays and scalars, we can go back to the definition, to the broadcasting definition. This describes how NumPy treats arrays with different shapes during arithmetic operations, and these arithmetic operations are performed element-wise. So one element and the other element. To allow these element-by-element operations, the smaller array has to be broadcast to match the shape of the larger array. When we use scalars, broadcasting seems fairly straightforward because it's very easy to duplicate the scalar to match the dimensions of the array that it operates with. But broadcasting can also work with arrays that have some sort of constraints. We have already seen how broadcasting works with scalars. Let's now take a look at broadcasting with arrays. You can only broadcast the smaller array over the larger if the shapes of the two arrays match exactly or they are compatible in some ways. Let's see what this actually means. So here are two arrays, and we want to perform some arithmetic operations between these two arrays. The arithmetic operation we want to perform is in an element-wise manner. The first array has a shape of 3 by 6. The second array has a shape of 3 by 1. Let's start off by looking at these dimensions in the reverse order. The last dimension of the smaller array is 1, and the remaining dimensions of the smaller array perfectly match the larger array, which means the smaller array can be broadcast over the large one for arithmetic operations. This we do by replicating the last dimension of the array to match the larger array. Once the smaller array has been replicated, the shapes of the two arrays perfectly match each other, and you can now perform element-wise arithmetic operations on these two elements. Let's consider another example here. We have a 3 by 6 array and a 3 by 2 array. Now notice the last dimension of this array. This is not equal to 1. In fact, this is equal to 2. The smaller array shape is different from the larger array, and its last dimension is not equal to 1, which means the smaller array cannot be broadcast over the larger array. Element-wise operations cannot be performed with these two arrays. We will get a broadcast error. Let's consider another example. We have the original 3 by 6 array. The second array is 2 by 1. The last dimension of the second array is equal to 1. However, notice the remaining dimensions do not match. They're 3 by 6 versus 2 by 1, which means the smaller array cannot be broadcast over the larger array, and element-wise arithmetic operations between these two arrays will not work. There will be a broadcast error. It's pretty clear from our broadcasting definition here that the shapes of the two arrays have to be compared element-wise, and they are subject to certain constraints before broadcasting is possible, and the dimensions of the two arrays they are compared in reverse, starting with the trailing dimensions and working forward. All right. So if broadcasting rules are met, that is all the remaining. That all the remaining dimensions are exactly the same, and the trailing dimension of the smaller array is equal to 1. Then the smaller array can be stretched to be equal to the shape of the dimensions of the larger array, and arithmetic operations can be performed element-wise on them. Now, there is one more thing that I need to mention, and that is that whenever we are working with broadcasting doesn't actually mean that there are actual copies being made. That is why broadcasting is very computationally and memory efficient. Broadcasting rules state that two arrays need to be of compatible shapes, and compatible means that all dimensions of the two arrays need to match, or one of the two dimensions need to be equal to 1, so that the array can be stretched to match the shape of the larger array. So, in short, broadcasting is a very powerful feature of NumPy, which allows arrays of different shapes to be combined together. It is memory efficient because actual copies of smaller arrays are not made. It is also computationally efficient because the looping operations under the hood are in the C language rather than in Python. We have seen that when we perform operations that are between an array and a scalar. Scalars are very easy to broadcast. They're just replicated along all axes of the larger array. You will never get a You will never get an error when you broadcast scalars, and scalar broadcasting is independent of the size and shape of the other array. Finally, when you might where you might run into trouble and you have to watch out is when you want to broadcast one array over the other. The shapes of the two arrays need to be compatible in some way, and then we start from the trailing dimensions and check to see whether the shapes match. Each dimension needs to match one or more dimensions of the other array. All right, so with this, these slides, they come to an end. So let's go ahead and let's actually talk about code. I know it's been 10 minutes, but I'm not going to wrap this lecture up. I'm just going to go ahead and I'm going to talk about the code for this lecture. So what we are going to do is, first we have imported NumPy in here. Then we have created two arrays, 1 to 5, and this array is 5 elements of 10. Both of the arrays have the identical shape, which means element-wise operations such as multiplication, etc. is possible. So if I say A times B and if I run it, this is going to be element-wise multiplication. 1 times 10, 2 times 10, 3 times 10, and so on and so forth. Let's initialize a scalar. So I'm going to say C and I'm going to set it equal to 10. Broadcasting always works when you perform arithmetic operations that involve an array and a scalar. Scalar dimensions can be thought of as 1, which means that scalar can be replicated to match the shape of the array so that this multiplication can be carried out. So if I say A times C, it is going to be like very easy. It's going to always work. Arithmetic operations which involve a scalar and multidimensional arrays can work as well. So let's say ones. I'm going to say np.ones. Let's create a 4 by 3. And let's first take a look at our ones. And then what I'm going to do is I'm going to grab the ones and I'm going to multiply it with the C. There we go. So we got 10 point. It's a 10 point. All the elements are of the same value, and the element-wise multiplication is actually possible. Let's take a look at how broadcasting works with arrays. So here I have two arrays, heights and weights. These are the heights and weights. Both of the arrays, they have 6 items. Let's say we have a student, provide an n here. We have a student bio array, which we are going to say np.array. And I'm going to provide here. So I want to provide all the heights and the weights as elements to this array. So I'm going to say heights, weights. Let's run that. Let's take a look at student bio. Okay, let's run that. There we go. So we got the heights and we got the weights. Let's say we want to convert the heights from centimeter to feet and weights from kgs to pounds. So I'm going to say factor 1. It's going to be np.array. So the factor for centimeter to feet is going to be 0.03 28084. And for kgs to pounds is going to be 2.20462. There we go. So this is our factor. Let's take a look at the shape of the factor. The shape of the factor is a 2. It has 2 elements, and it is a one-dimensional array. Now the shape of a one-dimensional array, as we have seen before, is 2, which is the number of elements in that one-dimensional array. And the shape of the student bio array is 2 by 6. Now, these arrays are not compatible for broadcasting. So when we try to multiply the student bio by factor 1, we will get an error. So student bio factor 1. If I run it, we are going to get an error. Operands could not be broadcast with shape of 2 by 6 and with the shape with 2. If we look at the last dimension of both of these types, both of these arrays, for the first array it is 6, and for the second array it's nothing. So we don't have anything in here. The last dimension for one of these arrays has to be equal to 1 for these arrays to be broadcast together with no error. So we need to have 1 in here in this. So what I'm going to do is I'm going to change the shape of the array that is used to represent the multiplication factor, so we can convert centimeters to feet and kilograms to pounds. And now I'm going to say factor 2 np.array. This is going to be, just going to copy this number, put it right here. Now this is also going to be 2 point something. Copy that, put it right here. Let's take a look at the factor. And now we can see that it is basically a 2 by 1 array. There are 2 rows, but there is 1 column. So factor 2 dot shape is going to have 2 by 1. Now 2 by 6 is the larger array. The smaller array is 2 by 1. And because these, both of the 2's, they match, and then we have 1, which is the trailing dimension, it can be perfectly broadcast over the larger array, which is 2 by 6. Now let's grab the student bio. Let me just grab that and multiply it with the factor 2. Let's run it. There we go. So what we have done is we have selected all of the heights, we have converted them to feet, and we have selected all of the weights, we have converted them to pounds. With this, our lecture comes to an end. See you in the next one.